So how to find the equation of the tangent to the circle? So there are three forms of tangents. One is point form, second one is parametric form, and third one is slope form of the tangent. Now what the meaning of point form is? Circle equation will be given and the point on the circle will be given, that is point of contact. You need to calculate the equation of the tangent at P to the circle. So let us take the circle equation as x square plus y square equal to a square and the point P x1 comma y1. So one method is you can calculate slope of CP and then perpendicular line slope, and passing to this point Px1 comma y1, you can write the equation of the tangent. Another method is using calculus. So differentiate the equation with respect to x and calculate the slope of the tangent at x1 comma y1. After calculating the slope, you can write the equation of the tangent. So let us use the calculus. So differentiate x square plus y square equal to a square with respect to x. So dy by dx equal to minus x by y. That means slope of the tangent to the curve, that is to the circle at x1 comma y1 is minus x1 upon y1. So without using the calculus also, you can get this slope because CP is perpendicular to the tangent, because radius is always perpendicular to the tangent at the point of contact. So slope of CP is y1 upon x1. So slope of the perpendicular line is minus x1 upon y1. So equation of the tangent at px1 comma y1 is y minus y1 equal to minus x1 upon y1 into x minus x1. So cross multiply and simplify. So you'll get x1 plus y1 equal to x1 square plus y1 square. But x1 comma y1 is a point on the circle. So x1 square plus y1 square equal to a square. That is replace x1 square plus y1 square equal to a square. So this we have written in the notation as t equal to 0. That is point form of tangent to the circle x square plus y square equal to a square at x1 comma y1 is x1 plus y by 1 equal to a square. So instead of taking the circle with the center origin, if I take the general form of the circle s equal to 0, x square plus y square plus 2gx plus 2fy plus c equal 0. So here also you can derive in the same manner, either using calculus or without using calculus, using the slope of CP and then perpendicular line. So and expand and simplify, then you will get the equation of the tangent in point form as x1 plus y1 plus g into x plus x1 plus f into y plus y1 plus c equal to 0. So here also, because the point x1 comma y1 lies on the circle, so x1 square plus y1 square plus 2gx1 plus 2fy1 plus c equal to 0. That we are using in this simplification to get the notation t equal to 0. So the second one is equation of tangent in parametric form, means you should have a parametric coordinates of any point on the circle. So let us consider x square plus y square equal to a square. So the parametric coordinates are p a cos theta, a sin theta. So we have to calculate the equation of the tangent at p in terms of the parameter. That's why it is called equation of the tangent in parametric form. Now, because you are having the point a cos theta, a sin theta, either you can apply the previous method, either calculus or calculating the slope, or else you can apply the directly equation of the tangent in the point form. So x1 plus y by 1 equal to a square by replacing x1 with a cos theta and y1 with a sin theta in this equation and simplify. So the equation of tangent in parametric form will be x cos theta plus y sin theta equal to a. Now this we have derived for the circle x square plus y square equal to a square. Now, if you want to have the equation of the tangent in parametric form for the general form of the circle s equal to 0, so the variation in these two is origin. That means we need to shift the origin to minus g comma minus f. Then we have to replace x with x plus g and y with y plus f and a with root of g square plus f square minus c. So this equation corresponds to equation of the tangent in parametric form for the circle s equal to 0, where theta is a parameter. No. So slope form of the tangent. The meaning of slope form is slope will be given and the circle equation is with given. So you need to calculate equation of the tangent with the given slope m. So if I consider m is the slope, I can consider equation of the tangent with the slope m as y equal to mx plus c. Now once this equation y equal to mx plus c is a tangent to the circle x square plus y square equal to a square. So the perpendicular distance from the center is equal to the radius. That is modulus of c upon root of 1 plus m square equal to a. So c square equal to a square into 1 plus m square, which is the condition of tangency. This we have derived before also. That means c equal to plus or minus a into root of 1 plus m square. Now write the equation of the tangent in the slope form. That is y equal to mx plus or minus a into root of 1 plus m square. Here plus corresponds to one tangent and minus corresponds to another tangent. Why? Because when slope is given, you can have two tangents to the circle. One tangent is this, another tangent is parallel to this above. That is ends of the diameter. So this is one tangent and this is the another tangent. So equation of the tangent in the slope form is y equal to mx plus or minus a into root of 1 plus m square, where m is the slope of the tangent. Now, in the same manner, we can derive for the general form of the circle s equal to 0 also. Rs by shifting of the origin concept, we can write the equation directly. So instead of y plus f, you have right, and instead of x plus g, and instead of a, root of g square plus f square minus c. Now, if I want to calculate the point of contact of the tangent in the slope form, so let us consider Px1 comma y1 is the point of contact of the tangent. Now, because x1 comma y1 is a point of contact, I can write the equation of the tangent in point form as x1 plus y1 minus a square equals 0, and the slope form is y equal to mx plus c, that is mx minus y plus c equals 0, where c equal to plus or minus a into root of 1 plus m square. So both the equations corresponds to the tangent only, but one is in point form, another is in slope form. Now both equations represent the same. So when two equations represent the same, so the coefficients are in proportion. That means coefficient of x ratio, coefficient of y ratio, and constant term ratio will be the same. So coefficient of x ratio, x1 upon m. Coefficient of y ratio, y1 upon minus 1. Constant terms ratio, minus a square upon c. So from this, you will get the point of contact x1 comma y1 as minus a square m upon c comma a square by c, where c equal to plus or minus a into root of 1 plus m square. So when I substitute c here, I'll get the 2 points. One point corresponding to one tangent, another point corresponds to the another tangent. So here, when I replace c, so the point of contact formula is plus or minus am upon root of 1 plus m square, and the y coordinate is minus r plus a upon root of 1 plus m square. So in the x coordinate, if I'm using plus, in the y coordinate, I should use minus, and in the x coordinate, if I use minus, and in the y coordinate, I should use plus. So point of intersection of tangents in parametric form to a circle. So let us consider the circle equation as x square plus y square equal to a square. So let alpha and beta are the parameter. So coordinates of the point P is a cos alpha, a sin alpha, and the equation of the tangent is x cos alpha plus y sin alpha equal to a. And the coordinates of the point Q, a cos beta, a sin beta, and the equation of the tangent at Q is x cos beta plus y sin beta equal to a. So we need to calculate point of intersection of these two tangents, which is t. So solve the system of equations and apply transformations and simplify. So the point of intersection of tangents t should be in terms of submultiples. That means it should contain the terms involving alpha plus beta by 2, alpha minus beta by 2 with the trigonometric functions. So the point of intersection of the tangents at alpha and beta with respect to the circle x square plus y square equal a square is a cos of alpha plus beta by 2 upon cos of alpha minus beta by 2, a sin of alpha plus beta by 2 upon cos of alpha minus beta by 2. So try to remember the formula. So how to determine the number of tangents from a point to a circle? So let us consider the circle x square plus y square equal to a square and the point px1 comma y1. So geometrically, we can decide the number of tangents easily. If the point P is outside, you can have two tangents. If the point P is on the circle, you will have only one tangent. If the point is inside the circle, there will be no tangent possible. Okay. Now, so how to decide the same mathematically? So to decide the same mathematically, so use the equation of the tangent in slope form passing through the point x1 comma y1. That is equation of tangent in slope form is y equal to mx plus or minus a into root of 1 plus m square. If it passes through the point x1 comma y1, so y1 equal to mx1 plus or minus a into root of 1 plus m square. So take mx1 to the left side and square it and expand and simplify. You will get a quadratic in m. For this quadratic in m, because here m corresponds to the slope of the tangent. So for this quadratic in m, calculate the discriminant. So the discriminant d equal to 4a square into x1 square plus y1 square minus a square. In terms of notation, it is 4a square s1. Now, when the point P is outside the circle, s1 is greater than 0. When s1 is greater than 0 means discriminant is greater than 0. When discriminant is greater than 0 means you will get two values of m, means two tangents are possible. So when the point is on the circle, s1 equal to 0 implies d equal to 0. Once d equal to 0 means this quadratic equation you will have equal root, means only one value of m is possible. That means only one tangent exists. If the point is inside the circle, then s1 is less than 0. So discriminant is less than 0. No value of m is possible. That's why no tangent is possible. Angle between the pair of tangents drawn from an external point px1 comma y1 to the circle x square plus y square equal to a square. So here also, to find the angle between the pair of tangents, let us consider theta is the angle between the tangents and m1 m2 are the slopes. Then we can get a quadratic in terms of m, and then we can write m1 plus m2 and m1 m2, and tan theta equal to modulus of m1 minus m2 upon 1 plus m1 m2. So from this quadratic equation, we can calculate m1 minus m2. Then the formula becomes angle between the pair of tangents is tan inverse of 2a root of x1 square plus y1 square minus a square upon x1 square plus y1 square minus 2a square. But this formula we have derived for the circle x square plus y square equal to a square. So if I want to convert this formula to the general form of the circle, I should use the notation. So in terms of notation, x1 square plus y1 square minus a square corresponds to s1. So that means tan inverse of 2a root of s1 upon s1 minus a square. Here a corresponds to the radius of the circle. And one more method of derivation is, if I join perpendicular, if I draw the tangent to the circle from the center, so these two triangles are congruent. So this angle will be theta by 2, and this angle is also theta by 2. So let us consider these points are A and B. So we should calculate length of the tangent. After calculating the length of the tangent, then you can have another formula also. So to find the length of the tangent PA, because it's a right angle triangle, so PA square equal to CP square minus A square. So CP square is x1 square plus y1 square minus a square. So length of the tangent from a point to a circle PA root of x1 square plus y1 square minus a square in terms of notation is root of s1. And the length of tangent is always same. So PA length and PB length both are same. So these two triangles are congruent. So the angle will become theta by 2 and theta by 2. So in this triangle, if I apply tan theta by 2, so tan of theta by 2 equal to a upon root of s1. Now, so from this also you can write theta equal to as theta by 2 equal to tan inverse of a upon root of s1, and theta equal to 2 tan inverse of a upon root of s1. So first formula is in terms of tan inverse, second formula in terms of 2 tan inverse. Even you can have a formula in terms of sin inverse also. How to derive that is, write sin theta in terms of tan theta by 2, which is 2 tan of theta by 2 upon 1 plus tan square theta by 2. Now substitute and simplify. Then theta equal to sin inverse of 2a root of s1 upon s1 plus a square. So depending on the problem, either you can apply the first formula or second formula or third formula to find the angle between the pair of tangents drawn from an external point to a circle.